security is kind of a buzzword, I kind of classify that into two different domains, okay, depending on your needs. There are two main reasons why you want security. The first one is because you want to have data security. You want your data to remain private. That's one big topic which is affecting you, but there is one which is even worse, and this is one of the reasons why you typically need both when talking about safety, is what if a security breach would enable you to compromise the safety of the system. So the typical use case is you have a vehicle, a car, and this car is actually, someone is using a security breach to get into the car and to corrupt a system which is supervising the safety of the car. And looking at cars, well, there are a lot of things, a lot of connectivity which are going on in cars. So this is, I would say, the Eldorado in terms of surface of attack. It's quite huge. You, of course, have things like the connectivity gateway, which is the main communication module which connects the car to the internet. But you have other things. You have Bluetooth, you have Wi-Fi, you have USB sticks, you have the CAN bus, which is available also through the diagnostic. So a lot of things which will enable you to get into this car. Okay. Now, there is one specific domain where security has been present and people have been looking at security for a long time now. That's IT. Okay. If you look at IT, well, actually, to prevent what you see on these left pictures, they are using a number of techniques or technologies which enables you to minimize the risk. Okay. Part of that is things like intrusion detection system. If something is actually going wrong, you want to know about it. Okay. Maybe having diversification. Okay. Having one server which is used for something, and then having a different server which is used for outgoing data flow, for example. Incoming versus data flow, incoming data flow versus outgoing data flow, which is different. Maybe you need something like DMZ. Okay. So these are technologies which are used, well, in the IT domain for many years now. Okay. Network isolation. Okay. You want to make sure that if you have a huge network with a lot of clients, everything is isolated through VLAN or physical isolation. Dedicated access control. Things like you want to have a gateway which is used for incoming traffic, and then another one which is used for outgoing. Don't mix things all together. DMZ, proxy, which has the advantage of breaking a protocol. So if you're exploiting something inside a protocol, a proxy would be something which will help you. And dedicated gateways with eventually different software versions, which are actually running on these different gateways. And IDS, intrusion detection systems, because you want to know what's happening in your system. So you want to have probes on sensitive area inside your network in order to figure out if something bad is happening. Not talking about antivirus and all these kind of things. This is more on the infrastructure layer. Okay. So now let's back. What is a connectivity gateway? What is a connectivity gateway in a vehicle? The basic one is something where you have two networks. So let's say 4G, Ethernet, and you want to have communication in between, and you want to control that. What you need as a basic feature is a firewall and a routing capability, because you want to be able to maybe NAT some traffic. That's actually not enough. You need also to be able to control, to make sure that your system is secure, meaning you need to be guaranteed that what is actually running in the system is what you need, that's secure with. And also you need to configure the gateway, and maybe also see what's going on inside the gateway. So how is this typically done these days? This is typically done using Linux. And gateways is one of the major markets where you find a lot of Linux. And this is typically what you would see if you want to have, maybe you want to store some secrets, or you need an HSM, you need a network stack because you're doing network traffic, you need internet driver, you need to store something, and then eventually you are able to run application. The bad thing about that is, well, you have no strong separation, and all the drivers are all inside the same space. This means that if you have a driver which is corrupted, potentially it will attack the complete system. From the security perspective, that's not a very good thing. You have no strong separation. What I mean with no strong separation is that you have a dynamic configuration. So you're able actually to separate processes, but these processes are separated dynamically through the configuration or through the execution of the application. And then you have limited access control. Okay, you have ELinOS, which enables you to do a number of things, but again, the control in the capabilities of the different application is something which is defined programmatically. Okay. And the worst thing is that you have a huge code base. You have a huge code base both inside the kernel, but also at the application level. Because if you're actually embedding inside the Linux application, you'll bring a lot of different packages. And these different packages is something which will increase the code size and which will make it really difficult to really know what is in your gateway and potentially identify all the security issues inside this gateway. Okay. So this was the views that we had before, but what's happening is we want more and more things. Okay. Now we want to be able to update the gateway. So we want things like OTA. We want to have cloud communication because we want from a vehicle to be able to send some data to a cloud, either Amazon or a private cloud from the OEM, in order to store some information about the vehicle. The main goal is doing predictive maintenance. Okay. And then having even more applications, like things like eCall, being able to place an emergency call, or having some virtual key application which is running on your cell phone. And this now brings even more things, because this actually brings new features which are completely separated. I mean, an eCall has nothing to do with the basic gateway feature. It just happens that hosting this inside the gateway is something which is convenient, because you have the CPU that's close to the outside communication domain, so it's a logical place to put these things. And of course, what we have done also is that we have increased the number of interfaces. Not only two interfaces, but now we are actually having Wi-Fi, Bluetooth, CAN communication, FlexRay, all these kind of things. Okay. Well, actually, you can still do what I mentioned before with the Linux. The only thing is you're actually increasing the complexity of the system. And these have different meanings. One of them is how do you actually develop the different applications. Now you have applications which are completely unrelated. And this is quite a big thing. So you are not developing anymore a small gateway on a team of a couple of engineers. Now you have big teams which are actually developing some appliance and some application which will be hosted by the gateway. And at the end of the day, you need to integrate that and make sure that everything works together. Based on Linux, well, you potentially are bringing additional frameworks. And these frameworks may have just simple things like version clash. Okay. Maybe one application needs one version of a framework, and another one needs another different version of this framework. And what about the interferences? Interferences in terms of execution timing, in terms of separation, things that executing in parallel. What about the life cycle? We're talking about security and safety. Security means that as soon as you found a vulnerability in the system, you need to be able to update the system. Security means before updating the safety, means that before updating the system, you need to re-certify it. Okay? So you have some kind of contradictory position. You have security, where you need to update fast, react fast, and safety, where you need to do a lot of qualification, a lot of testing in order to guarantee that the system is still stable. And by the way, how do you actually test the system? So lifecycle is different. How do you actually test the system? Because now you have a very complex system. And all the interaction between the different applications will be difficult to test on a complete system. Okay. That's just not related to security, but actually due to the increase of the complexity of the system, this will actually bring new challenges. And an hypervisor will also help you in that. So let's dig more into the example that we had before. What will be the implementation based on an hypervisor? Okay. Well, as you see here, what happened is that the first thing which is very visible is that we now have a set of static containers which are containing different applications. Not only application, but also drivers. So the principle, security by separation, is to ensure that each function is completely isolated. Okay, for this purpose, you cannot just take Linux isolation. You need a much stronger isolation. Stronger isolation in this case means that you need to have a static configuration of the system. Okay. you need to have a static configuration of the separation, meaning that everything is defined at the boot up of the system, and there is no way to change this kind of configuration. The second thing is we want to be able to run some certification processes. As mentioned in the previous presentation, the smallest the code base is, the best it is in terms of certification. Not only in terms of effort related to certification, but in terms of being able to do a certification. If you want to certify from the security perspective some code, if you are taking 20,000 lines of code, maybe this will be possible. If you are taking 100,000 lines of code, this will just be impossible. Not because of the effort which is associated with it, but due to the level of complexity of the system, the authorities will simply decline that, or should ask you to give so many proofs that it will be pretty much impossible to certify. Statically defined communication. I've mentioned before that we have completely static configuration. In this kind of approach, you need to be able to know upfront what are the communication links between the different applications, and not do things like in Linux where you are actually defining dynamically communication mechanism. User level drivers. Again, it's about isolation. You want to ensure that every piece of code is isolated and well protected against himself and against the rest of the system. And of course, no matter if you have user level drivers which are separated, you still are able to share them across multiple functions. Okay, a partition can also be seen as a function. The only thing that you need to control, and an hypervisor will provide you a way to control the communication flow between these different drivers, and eventually create separation inside the driver. Imagine that you have a secure storage, maybe some files you want them to be able to access by one function, and some other files can be accessed by a different function. Okay? An hypervisor will also help you in order to control the separation, even at things like file system level. And the last thing, but I will come back to that a little bit later, is mixed type of runtime environments. Depending on what you are doing, you may want to use Linux because it's a very good starting point, but maybe something else, maybe an RTOS will be something which will be better suited because it will provide you less overhead. Okay. So, one thing that you can actually do with an hypervisor is create software diversification. That's what you see here. What you see here is a simple gateway application where on the left side you have Wi-Fi, and on the right side you have Ethernet. What you actually want to do is to control the communication flow between Wi-Fi and Ethernet. Make sure that only some outgoing traffic, for example, goes to the Wi-Fi. Well, Wi-Fi is something where Linux is quite good at. Okay, so why not start with putting something like Linux on the to manage the Wi-Fi? And by the way, Linux can have its own Wi-Fi driver. It accesses directly the Wi-Fi. There is no overhead associated with that. On the Ethernet side, it's a little bit more complex. So in this example, what we're assuming is that on the right side, the Ethernet is a sensitive network. This is a vehicle network, while the Wi-Fi is the external communication. And what we're doing here, we want to have a very strong separation inside the vehicle. So what we're doing is, first of all, well, I want to use a network stack, which is not the same network stack as the one which is used in Linux. Why? Because if you use the same one, then eventually one single vulnerability will enable you to get from the outside to the inside by just exploiting this vulnerability. So the first thing is, okay, let's use something else, which is, in this case, a POSIX RTOS, which has its own network stack, which is a different baseline. No single line of code is common between the part which is handling the Internet and the part which is using Linux. The other advantage of that is, well, even if you find a vulnerability in Linux or in the RTOS, which you will find, you still have two barriers actually in the system. So everything, you may have vulnerability in Linux, but it will stay in Linux. And in order to get into the system, you need not only to exploit this vulnerability, but you need to find another one which is available on this RTOS. And the point is, well, by the time you are able to find a vulnerability on the RTOS, which may exist also, of course, you see, at the time, you have enough time in order to fix the vulnerability vulnerability in Linux and patch through OTA this thing. Okay. The other thing that we wanted to do is, in order to make the network stack very solid, very isolated, we also removed from this guest, this RTOS, the Ethernet driver. So now the Ethernet driver is also completely isolated. This enables you, for example, to say, I have an Ethernet driver which contributes to the safety of the system. I want to make sure that this Ethernet driver means contributing to the safety of the system. Could be things like, I want to make sure that the driver is not sending 1,000 packets per second just by mistake. Okay, so you actually want to certify this code for that. And isolating it using a different runtime, which will be much smaller, will also enable to make this kind of separation and certification. So we end up with something which could be implemented with just one Linux, with two network interfaces and something in between like a network stack. We end up in a clean separation where each of the function is isolated statically with predefined allocated resources in its own container. Okay. What I mentioned before is also isolation, but this time not across features, but across packages which are inside Linux. So what you see in this example is a system where I want to have cloud connectivity, Amazon for example. You want to have a routing feature, and you want to have an IDS function, which is something which is actually doing intrusion detection. This could actually, and as you see here, this is actually something which is done inside Linux. So you could have one single Linux which hosts these different functions. What we are doing is separating them inside different containers for various reasons. First of all, you can actually control the resources, memory resources, CPU resources, which are actually used by these containers. And the second thing is, well, you may want to update your Amazon Cloud Connectivity Framework and without impacting something else, because they may have some version conflict in terms of which frameworks are actually used by each of the implementation. So eventually, having this separation also ensure you to minimize the interferences in terms of runtime environment between the different applications, and by the way, to make the update much easier. Okay. It's easier because you don't depend on external frameworks. It's easier also because if you want to update a kernel, well, you can update your cloud connectivity, you can update the kernel, you can update all the application, and the rest of the system will remain completely unchanged. And because of static configuration, you are ensured that in terms of memory usage, in terms of CPU usage, well, this partition will have no influence on the other one. Talking about IDS, and remember what we had before. We had something like POSIX guest, which was the network stack, and then we had an Ethernet driver which was separated. Eventually, what you need in this kind of system is a little bit more than that. What we typically implement, and what is typically implemented in hypervisors, is a software configurable switch on top of the Ethernet. Why do you want that? Well, you want that because you want to be able to replicate inside your SOC, inside your software architecture, what you typically do in IT. You want to separate data flow. So from one single Ethernet interface, you want eventually to provide multiple virtual channels, and these virtual channels will actually be controlled and separated physically, well, not physically, but virtually by software through VLAN interfaces, for example. Okay? So you can actually ensure that you know exactly what connections are enabled inside the system. And this is ensured, again, through a static configuration. And you want, by the way, also to implement the use case that we had before, which is IDS. So you want to be able to observe the system. What you typically have in your IT infrastructure is things like switches. And these switches are implementing mirroring features. So you can actually see from the outside what's actually going on in the system. This is also what is typically implemented here. So you can actually go and implement this kind of architecture. So you have one single Ethernet interface, but maybe you have multiple functions which are actually trying to use an Ethernet flow. You use VLAN separation in order to send them to dedicated functions, dedicated partitions, dedicated guests, and you use a mirroring port, which is actually there in order to provide partition provide a specific application with all the data flow which is actually visible in the system. So you can actually analyze it in the background. I just want to stop this guest. Okay, so you're ensured that it's not stopping an application that eventually will be responding because you have some malicious software. You will actually physically completely stop the partition and the guest operating system. Of course, an hypervisor and security in general needs hardware support. So one of the key things is, well, you need to select your hardware properly, you need to analyze the hardware in terms of security, and I'm taking one example of what is needed here is, well, let's step back. One thing which is important in security is the surface of attack, okay? And the surface of attack is basically the API and what you're exposing to an application in terms of capabilities to interact with the operating system, okay? That's the API. The more feature you provide, the more possibilities you give to an external application to have malicious action on your system, okay? Now, in the example that I showed you before, we had something like Linux, which has a certain API to the kernel. An application has access to certain APIs. Then we are adding below that an hypervisor, which also has its own API. So the risk associated with that, and one of the commands that we get sometimes is, well, actually you're increasing the surface of attack, because an application now has access to the Linux kernel, but also to the hypervisor. So you can actually find more than just some basic API in Linux in order to exploit features of the system. Okay, so you need actually to find some ways to avoid that. The hardware is actually helping you for that, because what happened is that if you take ARMv8, for example, you have different privilege level. You have the supervisor, which is classic, that's where the Linux kernel is running. You have the user level, that's where an Linux application is running. And then the last level below that is the hypervisor. One of the answers regarding the surface of attack is, well, in ARMv8, it's not possible to go to hypervisor mode without switching first it's not possible to go to hypervisor mode without being in supervisor mode, which means that from an attackant point of view, from a malicious code point of view, if you're actually in user space and you want to find vulnerability in the hypervisor, first you need to find a vulnerability in the Linux kernel to switch to supervisor mode. Once you're in supervisor mode, then you can try to find vulnerabilities in the hypervisor, but not before. Some options that I didn't mention here is the security model in ARM, which provides another feature, which is trust zone, which enables you to create additional separation. This is used typically to run trusted execution environment, which provide secure storage feature. So this actually is a combination that I didn't want to go too much to complexity in this presentation. So my last slide. So some takeaways. Secure hypervisor provide a security foundation. Okay, this is one of the elements. Okay, you cannot select all the hypervisor. You need to select an hypervisor which has security-related certification, which provides a real separation, static configuration. That's one of the key points. You need static configuration because if you have something where you have a separation which is created dynamically, then potentially you find vulnerabilities to change this configuration. What basically an hypervisor enables you, and I've just shown some examples, is to replicate in a system, in a SOC, the architecture that you typically found in IT, okay? And gives you all the flexibility to control the data flow, to control different modules, and to control everything that you will have in the system. And enables, of course, observation, like IDS. And one of the things is it enables the support of increasing complexity of gateways. You want to have more and more features. And this feature will have impact on security, will have impact on safety, will have impact in integration. Okay? An hypervisor will help you on all of that. And of course, The last point is you cannot have security only at the software level. You need to also select the right hardware in order to provide you the security. I mentioned the execution mode of ARMv8. I could have also mentioned IOMMU type technology like SystemMMU, which helps you to separate also the memory accesses in the system.
Thank you very much.